Alright, let's check out solutions to the MCA packet for numbers 11 through 15. Number 11 asks us to find the geometric sequence, and these are actually all the same sequences that were in number 10, except for now we're looking for the geometric one. And we had said that B was the arithmetic one, so we can count that one out. Now geometric has to multiply or divide by the same amount each time to get the next term. So I can eliminate A, because if I look at the first term to the second term, I'd multiply by 1 to get the next term, the second one, but multiplying by 1 would keep me just at 1, so A doesn't make sense as a geometric sequence. Now, geometric sequences can go from negative to positive if you're multiplying through by a negative. So let's check C. Negative 2 times negative 2 would get me to 4. However, 4 times negative 2 does not get me to negative 6. So C is not the geometric one, meaning D has to be. And the rule there is it's being divided by 3 each time. So negative 27 divided by 3 gives me negative 9. Negative 9 divided by 3 gives me negative 3, and so forth. So that is the geometric sequence right there. Alright, number 12. Which of the equations represents the table below? We can do a couple things with this. You could, well, first, if you're really thinking, note that the y-intercept is right here. That occurs when x is 0 and it crosses the y-axis at positive 5. Well, two of these equations do not have a y-intercept of 5. A doesn't have one, and D doesn't have one, so we're eliminating 2 and down to B and C. So at this point, you could either find the slope, which will correspond to either 3 or negative 1, and figure it out that way, or you can just plug in some numbers so for x and see what we get. So if I plug in negative 1 for x in either of these, it'll have to work. So let's try B. If I do y equals negative 1, since I'm putting a negative 1 in here for x, it's really like a positive 1 when we do that, plus 5, I really have y equals 6. But this table shows that when x is negative 1, it's supposed to equal 2. So really we can eliminate B right now, but let's just make sure that C makes sense. So if I put negative 1 in for x here, 3 times negative 1 is negative 3, and negative 3 plus 5 does give me 2. And it should work for every single one there. So 3 times 1, skipping 0 because I know if I put 0 in here I get 5. We already know the y-intercept's 5. 3 times 1 is 3 plus 5 does give me 8, and then 3 times 2 is 6 plus 5 does give me 11. So we're looking at C for the answer to number 12. Okay, lots of different options to go through there, but that's one route. Alright, checking out 13. Find the slope of the line containing these 2 points. Here we're going to use this formula, which is on the MCA formula sheet. So you just figure out, okay, which point am I going to use as my first point, which one is my second point. Most students start with the second point and they say, okay, I'm going to take this y minus this y, because every point is set up as xy. So in this case, I would say this is x2, y2, x1, y1. All that really matters is you go the same direction each time in the same starting point. So 4 minus 3, subtracting my y's, over my 2 x's subtracted, negative 2 minus 7. And we get 1 on top and negative 9 on bottom, so negative 1/9 is what we're looking at for the slope there. Alright, so there we go, we got 13. And moving on to 14. What happens to the graph of f of x equals 4x minus 5 if the y-intercept is changed to negative 2? Well, in y equals mx plus b form, that is always the y-intercept. So our y-intercept right now is negative 5. So our graph right now, 1, 2, 3, 4, 5, crosses right here. If they change that to a y-intercept of negative 2, so this right here is negative 5, negative 2 is right here, that's going to raise my graph up 3 units. So the graph would be shifted 3 units up, and we're looking at C. All right, and lastly, number 15. Going to save some time with this one. I'm going to use the calculator, but it is important to figure out what the pattern is here. And it doesn't look like it's an arithmetic sequence, especially judging by the answers that are possible. We get some fractions and stuff in there, so it's probably geometric, meaning we're multiplying by something. So what I would do is take 36 divided by negative 27 and see what we get there. And what you can do is just reduce this into, so both of these are divisible by 9. So 4/3, and it is negative. Let's see if that's the case when I take negative 48 divided by 36. I could divide each of these by 12. And again, I'm going to get negative 4/3. So it looks like the pattern is that you can double check with taking 64 divided by negative 48. So it looks like we're multiplying by negative 4/3 each time. So I'm going to take negative 4/3 times 64 first. And I'm going to use my calculator to do this just to save on time. And then I'm going to take that times 64. And I get negative 85 1/3. And now I got to take that times 4/3 as well. So I'm going to take that times negative 4/3. And we end up getting 113 7/9. So we multiply through by this twice, and it looks like we get C.